Hello, and welcome everyone to the session about Prometheus. My name is Neil Hansen, and I'm a Senior Cloud Solutions Architect here at OpenNebula. For this session, we'll have the presence of two speakers. First, we'll have Jesus Vasquez from Grafana, who will talk about the new features that Prometheus will bring. Then we'll have Daniel Olson from Rise, he'll talk about the ICE data center and our on-premises cloud environment there. Welcome to both of you, and thanks for all the attendees joining us today. Remember, you can use the chat on the same page to send in your questions. But to begin, I'd like to briefly introduce the features that Prometheus can bring to OpenNebula. So it's mainly monitoring and alerting between Prometheus and Grafana. There is an OpenNebula exporter that works within OpenNebula that provides all the basic information about your OpenNebula cloud, the overall workings of the cloud itself and the systems around it. We also have the libvirt exporter, which provides the information specific to the virtual machines running on your OpenNebula hosts. And that all moves into the Prometheus instance that gathers all the metrics and from the exporters and provides alerts based on rules that you set up and on the provided metrics from OpenNebula. Then you can use Grafana, which will provide a dashboard to visualize all these metrics about your virtual machines, your hosts, and OpenNebula in a very convenient way, all in one place. Here's just kind of like a little bit of overview of how all this works here. The front-end server for OpenNebula is running the 1D daemon, which will also run a Prometheus node that'll pull the metrics directly to the Prometheus server. Additionally, the hosts, which run the OpenNebula libvirt and system probes, will also have the Prometheus node that reports its metrics to the Prometheus server. All this gets pushed to the alert manager to let you know if there's any issues going on in your cloud in a meaningful amount of time. And then you can also, of course, use the Grafana interface there to monitor all of your system as well. All right. And now I'll leave the floor over to Grafana. Jesus Vasquez, all yours.
Thank you, Neil, for the introduction. So my name is Jesus Vasquez. I work at Grafana Labs as a senior software engineer. But I'm also a Prometheus team member and a Prometheus TSDB maintainer since a few months. And the talk is going to be about Prometheus Azure in review. So first thing is to go through the highlights of the changes in 2022, and then we will talk about things coming up new in 2023. I'd like to mention first about some notes about the Prometheus growth. So these numbers here come from our Grafana installation. So any instance that's reporting analytics to us, instance running on our cloud or instances running anywhere else that have at least one Prometheus data source configured count here. So we are experiencing a great growth in Prometheus. And we are very happy about that. And also the amount of contributors on GitHub, the PRs, the activity on the CNCF Slack channel, it keeps on growing. So yeah, it's definitely a very active project, and yeah, it's growing a lot. So right, the first thing that happened in 2022, well, not the first thing, but like the first thing that I should mention is probably one of the biggest changes that came into Prometheus. We're talking about native histograms. It's still flagged as experimental, like just so that you know, but I know there's people already using it, so don't worry about it. And in case you don't know what native histograms are, I also added these two screenshots. On the left side, you can see how a classic histogram looked like. So you know when you're observing a histogram, you have like a list of buckets. And so on the left side screenshot, you can see on the y-axis the bucket sizes. So they are those measures like 1.0, 2.0. And so whenever you measure something, it goes into that bucket. And one problem that we had with these histograms is that the resolution was a bit limited. You couldn't have like 100 buckets or 200 buckets. And also, if you decided on the bucket sizes at the beginning and then you wanted to change them in the middle of, I don't know, after 3 months of using your histogram, you would run into some issues. So this and many other reasons led the community and people to work on high resolution sparse histograms, which was a very complex name that ended up being native histograms. And you can see on the right how new histograms look like. You can see that the amount of packets is can be as much as you want, because we have now what's called exponential resolution. So you can even draw images using these new native histograms. So yeah, the benefits, as I said, are like way more resolution on your observations, and also so they are more precise for like data science, like if you to do math calculations on your observations. Yeah, so this has been more than a year of work, and it hasn't ended yet. And it was a hot topic during the whole year. So there's been talks about this at KubeCon in Detroit, and also at PromCon in Munich, multiple of them. So I leave here all the links and the QR codes in case you're interested and want to do a deep dive. The other thing that the other nice feature that was added during 2022 was out-of-order ingestion. So this is a screenshot of me adding the pull request, but this was a joint effort between Ganesh, Dieter, and myself. And so what is out of order? So most DSDB series databases allowed you to like insert any a sample in any timestamp, whether that was the past, the present, or the future. But Prometheus didn't allow this. So you could only send a timestamp observed now and then consequent samples. And so this is problematic. And so this was okay for most scenarios, especially considering that Prometheus is a pool-based, or it was meant as a pool-based metric system at the beginning, but now has remote write. Yeah. But this is a problem if you think about, I don't know, IoT environments where, you know, you have devices that to save energy, they are kind of shut down and then they wake up and then they send their metrics. So you cannot really control when they're going to be sent. And also it's a natural scenario when you have a server and this server disconnects from the network for whatever reason. But it's still online. I mean, it's up, like the server is running, but it's not connected. So it's still gathering metrics of the system. Eventually gets internet again, wants to submit their metrics. So those metrics were lost. But now with this feature, they can now be ingested. And so this picture kind of represents it a little bit. The box out of order range head on the upper left side is the thing that we added. Now all the out of order samples go into that box. And then on the right side, the range head, that's what Prometheus already had, which is where the in order samples are being stored. And then whenever a query came, so now when a query comes in, we kind of join both heads and give you like a nice view of the data, not dropping any samples on arrival, which is what we all wanted. We also had a talk about this at PromCon by me and Ganesh. So if you are curious and interested on how this was technically implemented, you might want to take a look. Another nice addition last year is we heard some feedback from people. There are some companies that don't like to install every minor version that Prometheus releases. Prometheus releases every 3 weeks or so. So we understand that's a fast pace for some companies. So we introduced long-term support releases. 2.37.0 was the first one with 6-month support. But we are about to release a new one with up to 1 year. For Prometheus, long-term support means that we are backporting bug fixes, security, and documentation updates. So yeah, if this fits your use case, I hope that you enjoy them. And then I also wanted to mention Brian's change. This is particularly interesting to me, so that's why I reserved a slide for it. So, in Prometheus, time series are basically as a set of labels, label names, label values, and then a value, the observed value. So they typically, in the code, the data model for a label is a struct where you have two attributes, the label name and the label value. But when you have like a Prometheus server running with millions of active series in memory, you have millions of these labels in memory. So you not only have to store the names and the values of each label, but also the references to all those variables and attributes. So when we're talking about millions of these, it's actually adding up quite a lot. So Brian had this idea of, okay, what if we, rather than using this struct, which is like, you know, the most obvious thing to do, we go and store everything in a single string, which is what we have here, you know, like the label name, label value, label name, label value. Yeah, and so this was introduced in Prometheus 2.44. And this, I took this tweet from Twitter, where basically a user reported that his Prometheus was using 50% less CPU and 30% less memory. So this is obviously a major performance improvement in Prometheus last year. Right, so what's coming in 2023? Yeah, I was crafting last Monday the new release of Prometheus 2.45.0. Release candidate 0, and I was drafting the changelog, and I noticed that half the changes that we introduced in the last 3 weeks were native histograms related. So yeah, definitely more native histograms work coming up, but also there's also nice new features in many other areas. There's also more out of order work coming up. Native histograms don't have out-of-order support, and the reason for this is the TSDB, which is like the database within Prometheus, was kind of written in a way that we all only persist float observations, but native histograms have introduced this new concept, which is a bit more complex. It has all the buckets and all, you know, these numbers necessary for doing the calculations. So basically in the TSDB, there's now 2 appenders, one for the normal observations and one for the native histograms. And the second appender for the native histograms don't yet have out-of-order support. So we're going to have to work on that. Then there's also some bug fixes coming. Hopefully support for timestamps and deletion. So one of the things that was left out while we worked on out-of-order support was deleting series. I guess it's less used. You first want to have the data in, then you want to query the data, and then deleting the data is nice, but was left out. So that's why it wasn't prioritized. I have a contributor asking to help on this. So yeah, there's been progress. I'm not sure about the state right now, but hopefully we'll have it by the end of the year. And then also we'd like to drop the experimental label. Just so that you know, we are using out of order in production at scale at Grafana, and it's working out pretty well. So yeah, we think it's reaching a stage where it's stable enough. And then I'm sure I'm leaving a lot of things out, but there's a new LTS release coming up with up to 1 year support. It will come out in probably the next 1 or 2 weeks. We're also thinking about expanding the character support. What does this mean? So Prometheus series and label names are pretty strict about the characters you can use to name them. And people coming from other metric systems like, I don't know, Graphite, are used to using like dots on the names. This is not supported in Prometheus, but we understand that to like reduce the friction, maybe, and yeah, to expand the adoption of Prometheus, maybe it's an interesting addition. So I know there's like a community effort to expand this, and maybe we'll have some news by the end of the year. Then another interesting field is researching other types of chunk encodings. This is pretty technical, but basically we're using the same chunk encoding for all the chunks in Prometheus, and perhaps for some kinds of observations, if we use a different chunk encoding, we will also save quite a lot of performance and storage. So we'll have to research on that. And then another big topic is OpenTelemetry. This is gaining traction, especially from people coming from vendors like private vendors that want to use an open spec. And Prometheus today is alternative in the sense that we accept the spec and you can send metrics using it, but the user experience has yet to improve because, for example, metadata on OpenTelemetry metrics is lost after the series are persisted or after a Prometheus restart. And perhaps there's something we can do about that. Perhaps there's more things to make Prometheus one of the best backends for hotel metrics. And then I'm aware of a remote write refactor that will improve performance. The remote write is used for the push-based Prometheus. And I know more and more people is using this. So probably an improvement in performance there will help a lot of people. Again, I'm leaving a lot of things out for sure. It's a very active project. There's a lot of things happening. So yeah, you're also welcome to contribute. There's people looking at new PRs every day. So if you'd like to help, just reach out to me, and I'll try to help as well. So thank you.
All right. Many thanks for such a great overview and upcoming features, Jesus. And now it's time to see how Prometheus is implemented in OpenNebula with this talk from Daniel Olsson from RISE.
Okay. Hello, my name is Daniel Olsson. I'm a researcher at RISE. It stands for Research Institutes of Sweden. So we are doing research, data center related research. And to the left here, we can see the facility that we have up in Luleå, north of Sweden. And basically we have divided the facility into a number of different modules. And the module 1 and 2, there we are running a production data center with the cloud services. And then we have a module 3, it's a climate box. It's a whole data center where we can control the climate inside. We have a module 4 that is built in such a way that it's easy to rebuild the data center and try different configuration. And addition to this, we have wind tunnels where we can put a couple of servers and control the flow of air and temperature and humidity. And we are also doing research on liquid cooling and immersion cooling. And in addition to the data center, we have together with Luleå Technical University, 5G Edge testbed. And this is Telia and Ericsson 5G network that is deployed there. And in this network, a feature called local breakout is enabled. And this means that the traffic originating from within the 5G network goes out directly or locally. And at that exit point, we have deployed an edge node. It's a cluster of servers, which we provide access to companies and researchers and others that want to experiment with 5G and edge. And one example of an experiment we have done is to the right, you can see a drone with a video camera sending this video stream to the edge node, which was doing inferencing on the GPU. So we are using OpenNebula, that doesn't need any introduction here, to provide infrastructure as a service spanning edge and cloud. And we run the front end at the ICE data center, which provides centralized management access using the GUI API and CLI. We have then connected different clusters to this front end. So for instance, at the ICE data center and also at different edge sites. And as you probably know, the front end needs direct access to the edge nodes, the hardware. And this is why we have set up VPN tunnels from the edge sites to the front end at ICE data center. And together with OpenNebula, we are a member of the Cognit project, and our responsibility was to set up the edge and cloud testbed. So we used the same kind of blueprint that we already have to set up this environment. So we have already installed the OpenNebula front end at the ICE data center, and the plan here is for each use case site to connect their local compute using WireGuard VPN tunnel to the OpenNebula front end at the ICE data center. And if we look closer at the deployment, it's a high availability configuration consisting of 4 VMs, the blue boxes to the left. And we chose to use GlusterFS as a shared storage for data stores and FireEdge. We are also running memcached for user sessions. We have one VM acting as a load balancer. It is running Nginx, and it is also terminating the WireGuard tunnels. In addition to infrastructure as a service, we also provide a container as a service, and this we have used Rancher, that is an open source multi-cluster management and provisioning framework for Kubernetes, and we have clusters at both the data center and also at the edge sites. And to the right, you can see here that we are using OpenNebula virtualization to be able to partition the resources at the edge sites. So we have partitioned out a part of all resources to be used by the container as a service, and the rest is available as infrastructure as a service, as VMs, for instance. And to be able to easy access all the services we have at ICE Data Center, we have developed a self-service portal that we call ICE Connect, and it is handling users and projects and resources and provisioning and billing. We are using Keycloak as an identity manager to implement single sign-on to all the graphical user interfaces. So what about Prometheus? Are we using that at ICE Data Center? Yes, we are. For instance, we have a pretty big Ceph storage cluster with about 2 petabytes of storage. So we are monitoring the Ceph storage using Prometheus. We are also using Prometheus to monitor the Kubernetes clusters at edge and cloud. And we are using custom metrics to do billing with this Prometheus data. So we are injecting specific metrics. I will talk about that more later. And we are using the remote write that Jesus said will be more optimized to send the data for long-term storage to S3, and S3 is actually on the Ceph storage cluster as well. This goes to the data pipeline based on the Kafka. And maybe in the future we will use Prometheus to monitor and do the billing of OpenNebula resources. Right now we are using the accounting log for that, but maybe soon we can use Prometheus instead. So what about the custom metrics we have added to Kubernetes to do billing and resource monitoring easier? So this is one example. So this is the PromQL for generating how much GPU resources each pod is using any given time. So this is run every scrape interval. We are running it every 15 seconds. So and the bottom you can see one data point, and you can read out that 8 NVIDIA GPUs was used by which pod and which node it was running, and which namespace, and also which tenant. So that using this information, it's easy to keep track of who is using what, and also calculate the billing costs for that tenant. Another custom metric, or two actually, custom metrics we can see in this Grafana graph. So we are using Grafana for monitoring, doing nice dashboards. And right now we are looking at one single tenant and what CPU this tenant has reserved, and that is the green line. And we can also see the actual usage of this tenant. So that's all. Thank you.
All right, and that was a great presentation, Daniel. Many thanks for contributing to this 10th edition of the OpenNebula conference with such a great description of the implementation. I hope everyone in the audience enjoyed this session and enjoyed explanations and got a lot of information out of them. Don't forget that you can send your comments and questions through the chat. Thank you, and see you in the next session.